Sound knowledge of vector is required for these questions. Look at this parallelipiped. The vectors A, F, D, E, C, H, B, G, they are same, and so are the vectors D, C, E, H, A, B, and F, G. And also notice that the diagonals actually bisecting each other, which is something we're going to prove in middle part of the questions. Okay, find these three vectors just like that, show a bit of workings, and using the knowledge that these two vectors are the same, and call C as anything you like, and then you can get the coordinates of point C, right? And the next part is using the triple scalar product. You will be able to calculate the volume of the parallelipiped. Okay, take note of how you use the formula. It's very important. And then the part B is just a cross product of two vectors. And the reason they ask you to do this is that this vector is normal to both planes A, D, E, F, and B, C, H, G. There's some reason for it if you go on working on all the later parts. And so because the keyword here is that we should show this equation, so therefore you should mention that using this normal, and imagine that this is a point P and you form a vector AP like that, and then the knowledge that the dot product is 0, and you got this equation. And then as for the next part, since it's a parallel, again this is a use of knowledge of vectors, and so the equation would look exactly the same except for the constant part. And so your task to find the constant D in this case, and you can use any points, and here I choose point the B and to find D, which is -41. And then here it gets interesting right here. Again, using knowledge that these two vectors are the same, you need to find out the coordinates of the point H, and then because your task is actually to justify, not to find, so all I need to do is just show that the midpoint of AH is P, and the midpoint of CF is also P. Then my task is done. And to find the distance, well, just employ the formula. Now, one caveat is that a lot of students do not realize that you have to arrange the equation like this before you can use the formula in this form. So please write down this important note in your reference sheet. And lastly, I'm going to explain this a bit. Again, the keyword is 3SF, so you should put your answer correct up to 3SF. The coordinates were like something like this. Okay, imagine that this is from lateral view the plane ADEF, and this is BCHG. So this point S is on the plane and point T on the plane, and together three of them, S, P, and T, they are collinear. And so in a way, P is actually a midpoint of ST, and the distance of SP and PD are the same, which is this one, the value we calculated earlier in part D. And so what I'm going to I do here is that I construct the equation of line ST, and using the normal vector, okay, and the point P form the line, and then to find the intersection point at S and T, or rather at intersection points of the line with the plane ADEF and BCHG, and then I have the coordinates of my S and T. So I'll look at other videos later. All the best.